On this video, we will apply some of the knowledge that we have gained about blood typing in our earlier theory-based video. Let's have a look of a practical application. So here we are first going to define one individual's blood type, and then we are going to try to find him a good donor match. Why don't we get started right away? So our first individual, let's call him Mike. We have his blood sample here, and we want to figure out what blood type he is. So, we put some of his blood in each of these 3 wells on the blood typing slide. And we use antiserums to work out what blood type this individual is. First, we will add synthetic anti-A serum to the well labeled A. Let's see what reaction occurs. And we see that the sample remains uniform, so there is no agglutination. Well, we'll repeat the same process using a synthetic anti-B serum. And we add it on a well labeled B. This time we see that the sample occurs granular, so agglutination has occurred. And finally, we want to test if Mike is Rh positive or not. So we use synthetic anti-Rh serum, adding it to the well labeled Rh. Now we see that the sample appears granular, so agglutination has occurred. Let's record our findings to the chart. So for Mike, there was no reaction for anti-A present. There was a reaction, agglutination, for anti-B. And there was a reaction for Rh. Therefore, Mike has to be blood type B positive. Now, we want to figure out who could donate blood to Mike. And for that, Let's use our table that we created earlier. And what we see here is that the donor would need to be either B or O to match with a blood type B. And on our other table, we see even more detail. For B positive, donor is going to be O negative or O positive, or B negative or P positive. Let's find out the blood groups for our 4 willing donors: Kim, Ajax, June, and Frank. For this, we will analyze a sample for each of them as before, and we will see what happens while recording our findings to the table. First, Kim. With anti-A. We see that there is clumping. Agglutination has occurred. So Kim is positive for anti-A. For anti-B, again, we see that agglutination, the clumping, has occurred. So Kim has tested positive for anti-B. Finally, our anti-RH. Again, agglutination has occurred. See those little clumps. So Kim is also positive for anti-RH. This means that Kim's blood type is gonna be AB positive. Let's have a look of Ajax. For anti-A, we are definitely seeing agglutination. So Ajax is positive for anti-A. For anti-B, we see no agglutination. And for the RH, again, no agglutination. So Ajax is going to be A negative. Next, let's have a look of June. We take a sample of her blood on each of the wells. And we add the anti-A. Here we see no agglutination. For anti-B, we do see agglutination. And for RH, again, if we look closely, we can see some clumps there. Some agglutination has occurred. This makes June B positive. Our last sample to analyze is going to be Frank. We take Frank's blood sample, add it to each of the wells, and add the antiserums. For A, there is no agglutination. For B, again, no agglutination. And for anti-RH, no clumping, no agglutination. So this makes Frank O negative. Now that we have analyzed all blood types, let's return to our donor recipient table and have a look who could donate blood to Mike. If we look at the potential candidates, we will notice that the ideal candidate would be June. Her blood group is a complete match to that of Mike, both being B positive. And if we look at Frank as a potential donor, we notice that even though his and Mike's blood groups are not the same, this would still work. Since Frank is O negative, his blood cells have neither B antigen or Rh antigen. Therefore, his blood cells should not be attacked by the antibodies in Mike's blood. He's a potential donor. There you have it. I hope that we have managed to bring some real-world relevance to these donor-recipient interactions that we talked about earlier on.